Algebra 2, Common Core, conic systems. So what we're doing here is we're going to learn how to solve a system of equations. This is coming off of a lesson where we're solving three variable, three systems. These were equations of planes in 3 dimensions. We're going back to 2 dimensions, but we want to know where these things are going to cross. Now, what is this thing that we're talking about? We're going to see different types of equations here. This, where we have one variable squared, is a parabola. And I'm immediately spelling it wrong. Let me fix that. Parabola, which we know kind of looks like a smiley face or a frowny face. In this case, it would be a smiley face because it has a positive lead coefficient. And it's degree 2, so the arrows are pointing in the same direction. Now, if this was a negative x squared, then we'd see the frowny face. And then when no variables are squared, such as in this case, this is simply a line. And so what are the possibilities here? Well, when these things cross, we could have them obviously cross twice. They could be tangent, which means they cross once, or they could not cross at all. But that's basically it between a parabola and a line. 0, 1, or 2 points of intersection. And that's what we want to know. And we're basically going to use substitution to solve these conic systems. Now, it's called a conic system. Conic is you're referring to a cone because depending how you slice a cone, you could get a parabola or a circle or an ellipse or a hyperbola. We're not going to talk about all these different things, but we are going to talk about parabolas and lines, and in the next example, we're going to talk about how to solve a circle and a line. So let's look at this example. So this is a parabola linear system. Now we can't do the elimination method like we did here, where we add the two equations together, because they're different. Like this has an x squared, this does not. Like sure, I could get maybe the two x's to cancel out, but then I'll have the y's and an x squared. It just doesn't work when you're working with different types of functions, or not necessarily functions, different types of graphs and equations and things like that. So because we have a parabola and a linear equation, they are of course different. Substitution is the way to go. And one good method is if both of them equal y, well then they can equal each other. So essentially what I'm going to do is I'm going to substitute this y for what y equals over here. And that's going to give me 2x plus 1 equals x squared plus 2x minus 8. So essentially they both equal y, so I can equal them to each other. And now I have an equation with just one variable. Even what we were doing over here with the three variables, we were always trying to get, first it was combine 3 to 2 equation with two variables, then combine those to one equation with one variable. And we could solve equations that just have one variable. Now in this case, I see an x squared term, and I also have x to the first terms, but that's usually an indication that you want to factor this. So let's set it equal to 0. And so I'm going to minus 2x, get it all to one side. And actually, the x to the first terms here are going to combine to be 0, so they're going to cancel each other out. And I got to subtract 1 and subtract 1 here. I get x squared minus 9. And I could factor this, or I could add 9 and do square root, but I'd have to do plus or minus. It'd be the same either way. But if these didn't cancel out, then factoring would really be my only option. So that's what I'll do here. I'll go with factoring. And so factoring this, x squared minus 9, that's a simple difference of two squares. I got x plus 3 and x minus 3. And so I get solutions of x equals negative 3 and x equals positive 3. Now what you have to remember that when you're solving a system is you're solving for where like a graph crosses. For example, like if this line is crossing this parabola. In this case, we're going to get two different answers. One here and one here. But these don't go together. These are simply the x values of the two coordinates of the points of intersection. So I need to find the y values that go with them. And again, I'm going to use substitution. I could substitute these x values into either equation because it's a common point they both share because it's where they're crossing. Now, in my opinion, it's much easier to substitute into the linear equation than the parabola, but you could substitute it into either one. I'll choose to use the linear. Y equals 2x plus 1. So y equals 2 times negative 3 plus 1, and y equals 2 times positive 3 plus 1. Oh, that's 6 plus 1. We get y equals 7. So when I plug in a 3, I get a 7. And when I plug in a negative 3, that's negative 6 plus 1 is negative 5. So y equals negative 5. Now we're doing this algebraically, meaning we have to show all of this work. In this case of a parabola in a linear equation, we could just type this into our calculator in our y equals screen, and we'll see the picture, and we can visually see where it crosses. There's tools in our calculator to find the points of intersection, and we could also check it out on the table. But solving algebraically means the work here is worth most of the credit. The answer is just part of it. But we get two answers here, but we don't always going to get two answers. Sometimes we'll get one. Sometimes we'll find out that they don't cross. So let's try another one. Here's a conic system, but this time we have two variables squared, not just x squared like in this case, but x and y are both squared, and they actually have the same coefficient, which is a hint that this is a circle, and we worked with circles the other day as a refresher from geometry. Again, nothing's squared here, so this is a line. Now, unlike the parabola linear system, where I could set them both equal to y, that's kind of tough here because the circle is y squared. I could set it equal to y, but again, I'd have plus or minus a square root, and that would be kind of a mess to work with. I'm still going to do substitution, but I'm going to do it a little bit differently. I want to solve my line to be x equals or y equals. We're used to them being y equals like we had here, but it doesn't have to be. And it would actually, in this case, be easier to make it x equals because I could just subtract 2y on both sides. And these are not like terms 10 minus 2y, and I'm going to write it as I say it as 10 minus 2y. And so I solved for x. I could have solved for y. I could have minus x and then divided 2, and that would work also. But I'm trying to get one of the variables alone. It doesn't matter which one. One of them has a coefficient of 1. That's usually the easier one to work with. So x equals 10 minus 2y. Now what I can do is I could substitute 10 minus 2y in for x into the other equation. So the circle here is x squared plus y squared equals 25. Well, I can replace x with what I just found x to equal, and that is 10 minus 2y. So 10 minus 2y. Sorry, very sloppy. Let me clean this up. 10 minus 2y squared, because x was being squared, so I'm replacing x, and what goes in there is now going to be being squared, plus y squared equals 25. Here we get that binomial squared we see all the time in Algebra 2. And remember, you can think of it as 10 minus 2y times 10 minus 2y, or you could do the little shortcut. Some people call it FOIL. But the mental shortcut is square the front times each other double. So times each other would be negative 20y. We double it to negative 40y. And square the back. Negative 2y times negative 2y would be positive 4y squared. Plus y squared equals 25. Again, I see I have my variable squared n to the first, so that tells me let's set it equal to 0 and factor. So I'm going to rearrange it a little bit. I'm going to put the positive y squared first, and then actually we have more than just that. These are like terms here, 4y squared and y squared. That's a total of 5y squared. Then a negative 40y, and then I have 100 here and 25 here. I'm going to have to move this 25 to this side, so minus 25, making this a total of 75 equals 0. And factoring this, now one thing I noticed that I do have a GCF of 5. I could divide everything here by 5, but let me get my calculator out so I don't need to, in case I need it, let's see. Let me just get that up and running. Okay, here it is. So when I divide everything here by 5, I can divide both sides of the equation by 5. Essentially, I'm factoring out a 5, but because it's an equation, I can just basically divide it, and 0 divided by 5 is gone. And so let me use this space over here. I'm going to be left with y squared, because 5y squared divided by 5 is 5, minus 8y, negative 40 divided by 5, plus 75 divided by 5 is 15 equals 0. And factoring this, actually don't think I'll need my calculator, but it's good that I have it. Numbers that multiply to 15, let's see, 3 and 5, but they need to add to negative 8, so it's going to be a negative 3 and a negative 5, because negative times negative is positive. So I get my y values of 3 and my y values of 5. Again, this is a circle and a line. And just as we did with the parabola on the line, a circle on a line could cross in two spots, which I think is going to be the case here, the fact that I'm getting two y values. Or it could be tangent to it, where it crosses once, or it could not cross at all. But in this case, I believe we're going to get two solutions here. And I found the y values of those solutions. But now I need to find the x values. And just as we did with the parabola linear system, I'm going to substitute it back in. And in this case, I'm going to still use the linear equation, x plus 2y. So that'd be x plus 2 times 3 equals 10, using this here, just replacing my y values with my y values with what I found. That's x plus 6 equals 10 minus 6, x equals 4. And over here, that's going to be x plus 2 times 5 equals 10. That's x plus 10 equals 10. Subtracting 10, I get x equals 0. So my solutions are going to be 4, 3, and 0, 5. And that is it. So there's different types of conic systems we can have. The most common ones we're going to see are linear parabola, like we saw here, and a linear circle. But we got to figure out a way to plug them into each other, either both equaling to y or replacing one with the other type of situation, different forms of substitution, and a little bit of squaring, maybe FOIL, and most likely some factoring and plugging back in and getting solutions. So that's really how we do conic systems. All right, that's it. See you.